You're likely familiar with concept of a container, but what is a container? How does it work? For example, if I run a command docker run remove it and interactive alpine shell, you can see I'm inside a container, alpine container, and this is different process. I can do anything inside this container, and this will not affect my host machine. For example, I can run a command host name. You can see the host name of this container just random string, because Docker, when you run a container, it assigns random host name for a container. And if I run ps command here, you can see this shows me only two processes, ps command I run and shell with process ID 1. How does it work? Let's explore it, and I'm gonna show you mechanics behind containers, and we will try to recreate this behavior ourselves, but without using any containers at all, just using a Linux host machine. So let's begin. Let's begin. And to start, we have to understand something called namespaces in Linux. Namespaces is just Linux kernel feature that you can use to restrict a process you're running, what the process can see. You have different set of namespaces. For example, if you run a command man namespaces, you can see there are a lot of namespaces: cgroup, IPC for interprocess communication, network namespace, mount namespace, PID time user UTS namespace. So in this video, I'm going to use UTS namespace and PID namespace to recreate behavior we have seen with this alpine image I showed you earlier. So let's start. Let's start. To do this, we have to use something called unshare system call. What this does? Let's read what unshare does. You can run unshare, specify option, and program to run with arguments if you have any arguments for your program. Okay, let's run sudo unshare and UTS namespace with UTS namespace. What UTS namespace does, it allows you to isolate or create a new hostname namespace. Hostname namespace for your process ID you're running. For example, I can run sudo unshare UTS and run shell command. Run shell command. You see, I'm now running shell process, and I can type hostname. As you can see, it is laptop because I'm working on my laptop. Okay. Now let's spawn another terminal. I'm using tmax for this, and let's type hostname on my host machine. It is laptop. Okay. Now let's try to change the hostname from this shell process perspective. I'm running inside another namespace. Hostname container. Okay, hostname. You can see I changed hostname inside this container, you can say. And let's check the host name on my host machine. Again, host name, it is a laptop. It didn't change. Now, as you can see, we can use unshare command to spawn a process in different namespaces. And namespaces, as I already said, just allows you to isolate your process and put your process like in a box to restrict the process what this process can see. Okay, let's try another one. Let's try PID namespace. Actually, with PID namespace, it is a little bit more fun. Okay, let's run sudo unshare PID and give it a shell. All right. As you can see, I'm running unshare with PID namespace, and if I run ps command, what do you think will happen? When first time I ran this ps command inside PID namespace, I was actually confused, because if you run ps command, you can actually see all of the PIDs running on your host machine. But why is that? I thought we are in a different namespace and we have to be restricted what our process can see. I thought that my process will just, ps command will print just process ID 1 for this shell command I'm running, and process ID, I don't know, 10 or 8 or something for this ps command. But this behavior is different. And this is because how ps command work. If you type ps command, it gets information from virtual file system called proc. You can type ls proc and you can see a lot of process IDs in this file system. And it starts from the root, like proc, and you can say self namespace, for example, or you can get symlink to executable. But how can we get different root file system? So this ps command will show only these processes from different root, from the root of this new process we're creating in PID namespace. How can we do that? Well, we can do that with another command. We can use something called chroot command. Chroot command actually stands for change root. So we can create root for our process, and we can change root into this root, new root, chroot, and give this new root, and let's run a shell. As you can see, it failed to run shell command because it runs from different root, but this root does not have shell command. And because of that, it fails to run shell command. So we have to, for this root, we have to specify bin directory. For example, in your system, if you run shell, it runs as shell, because what is a shell? You can see the shell located in bin sh, user bin sh. So we have to create bin directory inside our new root, actually, here. But this is tedious work, because if I create binary directory, bin directory, inside this new root, I have to copy everything from my bin to this new bin. And for example, if we'll print all the dependencies, for example, for bash command, being bash, you can see we have to also copy all these runtime dependencies for bash to run bash. And to simplify this example, I'm just gonna copy already prepared file system from Alpine Linux. I will run cur command and we will download mini root file system for the Alpine Linux. Let's unzip it, extract everything from this Alpine and specify this root. Alright. Let's now inspect our root. As you can see, this new root now has bin directory, and as you can see, it has a lot of different executables inside bin directory. And now we can use chroot command, specify new root and run sh inside this. All right. Now we can run a process with new root file system. Because I will if I run pwd, for example, it just sees the part of the file system of my host machine. It can't escape its own file system. I can type, for example, cd ... to go higher in this file system. I can't access my host file system because this new shell process running inside different root. So this is cool. Now what can we do? We can actually combine these two commands. We can combine unshare command and change root command to create a container. Let's actually try to do this. Let's run sudo unshare pid chroot and root and run a shell command. What I'm doing here, I'm running sudo command because I have to run unshare command. It is a system call and I have to run it with root permissions. I'm running unshare command. I'm specifying PID namespace, and after PID namespace I'm specifying what command I'm running. I'm running chroot command, and for chroot command I'm specifying new file system for my running process. It is new root. And then I'm specifying what command I'm running. I'm running a shell. Okay, let's give it a try. All right. Now I can run, for example, who am I? I am root. Okay, that sounds right. And if I try to run another command, ps command, oops, it didn't work. It says out of memory. And this is because we have to specify another option, the unshare command. Now when I run unshare command, I'm running this chroot command not as child from unshare. I'm actually running it as child from sudo. So I have to run this chroot command as a child of unshare command. So I have to specify another flag called fork. And now if I run who am I and ps command, as you can see, it shows nothing, but it works. But it shows nothing. It shows nothing because it didn't have anything inside this proc virtual file system. So to make it work, we have to mount we have to mount this proc file system inside this process. So we have to do mount, specify a type of mount. We're mounting proc, proc. And now if I run ps command, it shows exactly what it have shown in the docker command. It only sees its own process tree. As you can see, this process, shell process I'm running, has process ID 1, and this ps command has process ID. So we achieved the same behavior as a Docker when running a Docker, and we're just using chroot with unshare. So this is cool. This is cool. I hope this was useful for you, and now you understand how containers work and how they differ from virtual machines, because this process running on the same host machine. I am not creating anything special for it. This is possible just because of these Linux kernel features called namespaces. And by the way, I mentioned cgroups. With cgroups, you can, if with namespaces, you can restrict what process can see. With cgroups, you can restrict what resources process can use. For example, you can throttle CPU usage or memory or disk I/O, anything like that. So I hope this was useful. Thank you for watching. Bye.